Welcome to a new section. In this video, we are going to study the characteristics of image formed by lenses. By using ray diagrams, we can easily understand image characteristics. For that, first we are going to study three common rays used to draw ray diagrams. You need to consider any two of them to draw ray diagrams. First, incident ray parallel to principal axis. Let us understand it by drawing a convex and a concave lens. Draw principal axis for the lenses. Mark focus f1 and f2 for both the lenses. So here we are considering the incident ray parallel to the principal axis for both the lenses. For convex lens, this ray will pass through the principal focus on the other side of the lens. For a concave lens, this ray will diverge such that it appears to be coming from the principal focus located on the same side of the lens. So this is one ray we are going to consider for drawing ray diagrams of lens. That is the incident ray parallel to the principal axis. The second ray we are going to consider here is for a convex lens, the incident ray passing through the principal focus. For a case of concave lens, the ray is incident ray appears to be meet at principal focus. So we are going to draw the figure for understanding it. For that, we are going to draw a convex lens and a concave lens. Let us draw the principal axis. Mark the focus f1 and f2. Here also the principal focus is f1 and f2. For a convex lens, we are going to consider the incident ray passing through the principal focus. So the ray is such that it passes through the principal focus. But for a concave lens, the incident rays appears to meet at the principal focus. The ray is such that it appears to meet at the principal focus. So here the second ray is the incident ray passing through the principal focus for convex lens, and for concave lens the incident ray appears to be meet at the principal focus. In both cases, after refraction, the ray emerges parallel to the principal axis. So in both the cases, the ray emerges parallel to the principal axis. The third ray we are going to consider here is a ray passing through the optical center. So for understanding it, we are going to consider two lenses again, that is convex and concave lenses. Let us draw the principal axis. Mark the principal focus f1, f2 for both the cases. Also mark here the optical center O. In this case, we are going to draw the light ray passing through the optical center. In both the cases, the light ray passing through the optical center will pass without any deviation. So we studied three rays which can be used to draw ray diagrams. We need to select any two of these rays to draw ray diagrams. First ray we considered here is the incident ray parallel to the principal axis. After refraction, it passes through the principal focus on the other side of a convex lens, and for concave lens, it appears to be diverged from the principal focus of the same side of the lens. The second ray we considered here is the incident ray passing through the principal focus for convex lens, and the incident ray appears to meet at the principal focus for concave lens. And after refraction, both rays will emerge parallel to the principal axis. And the third ray we considered here is a ray passing through the optical center. It passes without any deviation. So by using these three rays, we can draw ray diagrams for convex and concave lenses for different positions of object. So now we are going to study image formation of lens at different positions of the object, and also we will study the image characteristics. So image formation by convex lenses. Here we are going to study 6 types of image formation based on the position of the object. First, object is at infinity. We know if object is at infinity, the rays are parallel to the principal axis. So we draw a convex lens, we draw the principal axis, we are going to mark the principal focus f1, f2 and the optical center O. So here, since the object is at infinity, the rays are parallel to the principal axis. We know if the rays are parallel to the principal axis, it will pass through the principal focus. So the image is formed at the principal focus of the other side of the convex lens, that is at f2. So here we are writing the image characteristics, that is image is formed at f2. Second characteristics is that we can see it is of point size, that is highly diminished. Or we can say it is of point size. Third is it is a real image. We know a real image is an image which can be observed if a screen is placed here. So it is a real but inverted image. So we studied if object is placed at infinity, the image is formed at f2. It is a highly diminished point size image and it is real and inverted. Second case is if object is placed beyond 2f1. Here also we are going to draw the ray diagram to understand the image characteristics. So we draw a convex lens, we draw the principal axis, mark the positions of optical center f1, 2f1, here f2, 2f2. We can extend this principal axis something more here to draw the object. Now we are going to place an object beyond 2f1. Now we need to select two rays and draw the ray diagrams. First ray we are going to consider. Here is a ray parallel to the principal axis. So this ray will pass through the principal focus on the other side of the lens. Second ray we are going to consider. Here is a ray passing through the optical center and we know it will pass without any deviation. Now we can see the image is formed here. That is, the image is formed between f2 and 2f2. We can also see the size of the image. The size of the image is diminished because the size of the image is less than the size of the object. We can also understand the image is real and it is inverted. So for the second case, it is when object is placed beyond 2f1, image is formed between f2 and 2f2. It is diminished, real and inverted. Now we are going to study the third case, that is when object is placed at 2f1. We are going to draw a ray diagram for this case. For that, draw a convex lens, draw its principal axis, mark optical center O, f1 to f1, here f2 to f2. In this case, the object is placed at 2f1. Now we are going to draw two rays. One, the ray parallel to the principal axis, and we know after refraction it will pass through the principal focus on the other side. Second ray we can consider here is a ray passing through the optical center, and this ray will pass without any deviation. So you can see the image is formed at 2f2. So here you can observe image is formed at 2f2. And what is the size of the image? You can see it is having the same size that of the object. Third point you can observe here is that the image is real and inverted. So if the object is placed at 2f1, here the image is formed at 2f2 of same size, real and inverted. Now we are going to study the fourth case here, that is, if the object is placed between 2f1 and f1. Here we are going to study by drawing a ray diagram. For that, draw a convex lens, draw the principal axis, mark the positions of optical center f2, 2f2, f1 and 2f1. Place the object in between 2f1 and f1. For understanding it, we need to draw two rays. First ray we are going to consider is a ray parallel to the principal axis, and we know after refraction it will pass through the principal focus on the other side. Second ray we can consider here is a ray passing through the optical center. We know this ray will pass without any deviation, and here we can observe the image is formed here. That is, the image is formed beyond 2f2. Also you can see the size of the image is larger than the object. So it is enlarged. We can also see it is a real image and inverted. So when object is placed between 2f1 and f1, then the image is formed beyond 2f2. It is an enlarged image, real and inverted. Now we are going to study the fifth case here, that is, if object is placed at f1. For understanding it, we can draw the ray diagrams. For that, draw convex lens, draw the principal axis, mark the optical center O, f1, f2, f1, f2 and 2f2. In this case, we need to place the object at f1. Now we can draw the ray diagram by considering the two rays. First ray we are going to consider here is a ray parallel to the principal axis, and we know after refraction it will pass through the principal focus on the other side. Second ray we can consider here is a ray passing through the optical center. And we know this ray will pass without any deviation. And now you can see these rays are parallel after refraction through this lens. That means it will meet at infinity. So image is formed at infinity. What about the size? We can also see the image is formed at infinity with a very big size when compared to the object. So the image size is highly enlarged, or we can say it is infinitely large. And third property we can observe here is it is a real image. So if we could able to place a screen at infinity, then we can observe that image on the screen. So it is real and inverted. So if the object is placed at f1, then the image is formed at infinity. It is highly enlarged, real and inverted. The last type we are going to study here is if the object is placed between f1 and O, that is in between f1 and optical center. For understanding this, again we are going to draw the ray diagram. For that we can draw the convex lens, draw the principal axis, mark the positions of optical center f1 and 2f1, also f2 and 2f2. Now we are going to place the object in between f1 and O. For drawing the ray diagram, we need to consider two rays. First ray is a ray parallel to the principal axis. We know after refraction, the ray will pass through the principal focus on the other side of the lens. Second ray we are going to consider here is a ray passing through the optical center, and this ray will pass without any deviation. We can see these two rays are diverging, so they will not meet at any point. But if you extend these rays, you can see these rays appear to be coming from a point. So an image is formed here. That is, image is formed on the same side of the object. So the image is formed here. What about the size of the image? You can see the size of the image is enlarged. That is, size of the image is bigger when compared to the size of the object. This image is not real because it appears to be coming from this point, and if we are placing a screen here, we cannot obtain the image on the screen. So it is a virtual image, and also you can see it is erect. So if object is placed between f1 and O, then the image is formed on the same side of the object. It is an enlarged image, virtual and erect. So here we studied image characteristics of convex lens based on the position of the object. Now we are going to study image formation by concave lenses. So here we are going to study two different types of image formation by concave lenses based on the position of the object. First case is when object is placed at infinity. For understanding it, we can draw the ray diagram. For that, draw a concave lens. Draw the principal axis. Mark the positions of optical center F1 to F1, F2 and to F2. In this case, we know the object is placed at infinity. So, the rays are parallel to the principal axis. We know if rays are parallel to the principal axis for a concave lens, then these rays will diverge such that it appears to be coming from the principal focus on the same side of the lens. That is, it appears to be coming from F1. So in this case, the image is formed at F1. That is the principal focus on the same side. We can see the size of the image is highly diminished. That is, the size of the image is point. So, the size of the image is highly diminished or point sized. Also, you can see the image is virtual because it appears to be coming from the principal focus here. So, it is virtual and erect. So, if the object is placed at infinity for a concave lens, then the image is formed at F1. It is a highly diminished point size image. It is virtual and erect. Now we are going to study the second case, that is, the object is placed in between infinity and optical center of the lens. So, for understanding this case, we are going to draw the ray diagram. For that, we can draw a concave lens. Draw the principal axis. Mark the positions of optical center O, F1 to F1, F2 and to F2. Here the object is placed in between infinity and the optical center. For drawing the ray diagrams, we can consider two rays. First ray is a ray parallel to the principal axis. We know after refraction, this ray will diverge such that it appears to be coming from the principal focus F1. Second ray is a ray passing through the optical center. We know it will pass without any deviation. So these two rays are diverging rays. So it will not meet at any point here. But you can see these two rays are coming or appear to be coming from a point here. So we can observe an image here. So in this case, the image is formed between F1 and O. What about the size of the image? We can see the size of the image is less when compared to the size of the object. So the image is diminished. Also you can see it is a virtual and erect image. So if the object is placed in between infinity and optical center of the lens, then the image is formed between F1 and O. It is a diminished image, virtual and erect image. So we studied two cases of image formation for a concave lens based on the position of the object. Thank you for watching this video. Keep learning. If you are not yet subscribed to our channel, please subscribe it. Also, please like and share this video.